Well, hello again. We're going to hopefully fix this thing this time. I dug around out in my bench in the shop, and I came across a couple of these variable, volume controls and on-off switches. This one here, I thought, man, this is going to be great. It's almost the same size as this one. This is a little bit smaller, but it's 50K, no good. We need 500, and lucky me, I bought a 500. I thought there was one out there. I found it. I bought it quite a while ago. 500K with a switch. And this is it right here. Considerably smaller, unfortunately, but that's what I told you. These newer, more modern types are a lot smaller. Now, I don't care about the size of the switch or the volume control. I care about the size of the shaft. It's easy to check these things out. You only have 3 tabs on the volume control. I connected one of my meter leads to the middle and one to this end. And now I'm just going to turn the shaft and you watch the meter. And you watch how smooth it'll work. Get this light out of the way a little bit. See it going down, 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 nice and smooth all the way to the bottom. Okay, cool. Now we're going to take the one on the outside. We're going to leave the one in the middle. I'm going to take the one on the outside, move it over to this other tab. This is an up-down volume type of thing. Hook that baby like that. Now we'll turn the shaft again, and you'll see it go down the other way. Down, 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 down. Nice and smooth all the way. That's the way it's supposed to work. Now let's try the on-off switch. The on-off switch is these other 2 tabs on the back. We're going to hook one there, and we're going to hook one here. Just like that, nothing to it. Now you see we have zeros. Now what I'm going to do is I'm going to turn this thing off. Well, it's going to be easier said than done, I guess. Let me see if let me lower this thing. It might help, where I can get a hold of this this thing. Yeah, I think we can do it now. Let me get a hold of it here. Here we go. Okay, it's off. And it's on. Okay. Off again. Alright, good to go. This thing is fine. It's supposed to work. So I'm going to get my finger out of the way. My finger's fine too. It's fine. It's good to go. Okay. Now let's do the same thing with the one that's in the radio. We hook one to the center, which we already have done. If I can find the black one, here it is. We are going to hook one to the center and one to the one of the outside tabs. Then we're going to turn this shaft and let's see what happens. Now I am in the 2 meg scale on the meter because this is supposed to be 500 ohms. We shall see. See it jumping around everywhere it's not supposed to be? Check that out. I'm pretty sure that's what's causing our problem with this thing to, we get our sound then we don't get it. Now I'm all the way at the 0 point. Works pretty good in a very, very lower position. But going up the other way, it begins to jump around. See, look at that. We're shooting there. 1 meg, 1.5 meg, almost 2 megs. Alright, now let's move this to the other connector on the other side, just like we did in the last one. And let's see what happens again. Yeah, see it jumping around? Well, it's almost there. Then it's a dead spot right there. Yeah, it's totally dead all the way to the bottom. Now these solder pins here, the lead pins, are straight out, and these are not. So I'm going to take my little duckbill pliers. I'm going to make them straight out. Be a whole lot easier to solder to than have them bent over like that. And it's going to be rough enough because the holes are pretty small. Let's get them straight. Well, there you go. Looks fine, lasts a long time. Now we'll go ahead and get it in. One more thing we'll have to do, we got to get rid of this tab. This tab normally fits in a hole in the chassis and keeps the whole thing from moving, from turning around. I don't know if you can see that over here. Got to break that tab off. And there wasn't nothing to it. There it is right there. You just grab it with your duckbill pliers and raise up. Pops right off there. Nothing to it. She's in, but these tabs now are just a little too close to the chassis for comfort. So I'm going to bend them back just a little bit more. A little too close. Well, let's see what happens. Hopefully we get something. Not very much volume. Still got problems. I wonder what that is. At least the volume is working now. Alright, we have the volume fixed, but it's being cantankerous. It only plays on, I checked all the blades, none of the blades are touching. It sounded almost like that. At bottom and top, I checked everyone very closely, and now she's stopped out again. I think I'm having a capacitor breakdown. It was playing fine a few seconds ago, then it just quit. Oh well, let me see the other bands. Nothing there. Alright, I'm going to work on it tomorrow. Right now I want to watch the rest of Mr. Holland's Opus. I'm watching that movie for the second time. I think it's a great movie. I just really liked it. Well, it's the next day, and during the night, while I was watching the Mr. Holland's Opus movie, I decided, I need to dig out my little Heathkit signal tracer IT12 and probe around in here and see if I can't find a bad capacitor. Now, normally actually they're all bad, okay, but I'm just thought maybe I'd do a little probing around for you new folks who've never done this before or never seen it done. And see if we can't pick up a signal, maybe listen to it on one side of a capacitor and on the other side of a capacitor. Namely your coupling capacitors, which couples one section of the radio to the other. They don't just hardwire them in, they put a little cap between them, Anyway, what we're going to do is take our little probe. Now, what is a signal tracer? A signal tracer traces signals. A radio signal comes in, that's a signal. Guy talking in a microphone 20 miles away, that's a signal. That's what I'm looking for. A radio signal. Music, doesn't matter. Football game, doesn't matter. And we're going to poke around here using our road map, our little schematic. We're going to go ahead and see what we can find. Now, I'm kind of on this noisy stuff. I'm kind of focusing on this last coupling capacitor right here between the 75 and the 6F6. This side here, if it sounds good, we'll take our little probe and we'll put it on this side of the capacitor and see what it sounds over here. Now, I don't expect it to sound very good because these are old caps, okay? Right now, I'm thinking that my primary problem is probably this capacitor right here. So what I'm going to do is, if I have good sound over here and crappy sound over here, but at least some decent sound, then I'm going to go ahead and clip this thing out of the circuit and see if it improves at all. If I clip it out of the circuit and I get pretty much the sound that's on this side of the capacitor, which it's not going to be very good sound. But right now, over in this area, I'm getting nothing. So it's got to be in this area right here, So let's go ahead and have a little fun. Now look, you new guys need to stay out of the bottom of these radios if you don't know what it's all about, okay? There are dangerous voltages in here. if you don't know how to use a signal tracer, if you don't know how to probe around safely with any kind of a probe inside of an old radio chassis, then stay out of there. Stop. Go to somebody that can show you how to do it or learn how to do it. Just be very, very careful, okay? These things can kill you. Safety is always paramount when you're dealing with the bottom of this thing once power is applied. It's one thing, you know, to change out crap and everything when there's no power. Hasn't been any power for years, and you go in there and you start changing out resistors and things. Not a problem. But the second you plug it in, it's a whole new ball game, okay? And trust me, I know. I've been shocked so many times. And I'm very, very safe with these things. I do my very best. You know, I see guys all the time working on these things, probing around with rings on their finger, which is really stupid. That is, and they'll have watches on, metal watches. Stupid. Stupid, stupid. You know, don't wear necklaces, rings, or jewelry when you're walking, you know, probing around on the inside of this stuff. They're so used to, a lot of them, they're so used to probing around on the new stuff when you're dealing with, you know, low voltages, 3-4 volts. But these babies here, these are 300-400 volts. Be careful. You know, get those rings, watches, and jewelry off before you start probing around, and know exactly what you're doing before you do it. Okay, now what I'm going to do, like I said, is I'm going to probe on this side of the capacitor first, then I'm going to probe on the second side. And it's coming out of this speaker here. It's also coming out of this speaker over here too. See if I can get a better tune here. About the best we're going to get, I guess. Alright, let's probe around on the left hand side of that thing. Not a lot cleaner. Okay, let's turn up the voice a little bit. Pretty garbled here. A little clearer there. So that's what's making me think that capacitor on the back of the speaker plug feeding the speaker is bad. This one right here. Now let's go to the other side. First of all, go back to the left where we started. It's not too bad. Let's go to the other side. Now, you don't think that capacitor is bad? Pretty bad. It's terrible. They're leaking like crazy. What is this, 1936? What is that, 88 years? Of course they're bad. I just wanted you to see what you could do with a signal tracer on one side and the other. Let's go ahead and clip this thing out of here, because I've got to change it anyway. Since I got to change it anyway, let's just go clip one side and pull it down. By clipping it, I'm talking about it'll be either this side or this side. We'll just clip it out of the circuit on one side and see if it improves the speaker at all. Because, you know, there's no doubt, I have no doubt that it's leaking like crazy. Right, get this stupid thing over here. I have no doubt that it's leaking right across that thing, no problem at all. So let's get it clipped. Alright, she's clipped with the power off, of course, with the power off. Now I got to turn it back on. Let's see what happens here. Crank up our little, do a little ground here. Still not very good. Alright, now let's go down and test our other capacitor as well. Where are you at now, booger? That's the same capacitor we tested last time. Let's test the other side. Still pretty bad, huh? Let's run through this. Let's run through the stations. Yeah, see, we're losing it again. We got really bad cap problems. But we are picking up more stations now. Now the cap I just clipped out of there, the number on the body looks like a 100-15. Looks like a 15 to me. How about you? But if you go over to the parts list, you'll see that there is no 115. Well, that, you know, again, you're going to run into this sort of thing, you know. Is that a mistake on the capacitor, or is that a mistake on the parts list? Well, actually, it's neither, because I figured out that this is a 110, not a 15, even though it looks like a 15. Even looks like a 16, huh? But it's 100-10. Very bad printing. So, but how did I figure that out? How did I know that? Well, let me tell you. This thing here has a working voltage of 600 volts, if I can find it on here. These are the worst capacitors I think I've ever seen in my life as far as labeling goes. It's supposed to be on there, but I know you're having trouble seeing it, but the working voltage is 600 volts for this thing, even though they really don't tell you. Anyway, I knew this from what my mentor Brendan told me many years ago. This capacitor right here is always higher voltage than the rest. So this would have been, all the rest of the capacitors in here are rated at 200 volts. This thing here would be higher than 200 volts. Well, which of these down here, back up here a little bit so you can see, very important. All the rest are rated at 200 volts. Say it's 200 volts right there. Here's one at 400. But here's one at 600, the highest of all. It's a 0.006 at 600 volts. This thing here is always the highest voltage, usually the highest capacitor voltage in the chassis, because it deals with spikes coming through here. Okay, it's to remove the spikes to where this is the way I remember him telling me. It'll take away the spikes and enabling keeping the audio output transformer from being burned up, and hence the audio the voice coil itself. So this is a kind of a little protective thing. I've seen these things rated at 1600 volts. Yes, I have. I have a radio where I think I still have it. It's rated at 1600 volts. These are always the high. This little baby right here is always the highest voltage one that I have found in all of the chassis. It's a protective thing. But it doesn't do very good, I don't think. But, you know, seems to me I used a safety capacitor for that one time, a long time ago. I think it was a 1600 volt safety cap I put in there. Anyway, just keep that in mind. You know, you'll see this a lot. Remember, this is a cheapo radio put out during the height of the Great Depression in 1936. They were made cheap because people couldn't really afford them. And you know, generally speaking, whatever radio they had when the Depression started is the one they stuck to until it was over. And they put pieces in parts and did all kinds of stuff. You know, Uncle Billy Bob, you know, he knew all about radios. He'd come over and fix anything. You know, he'd go to his car, get a part out of the motor, and come over and fix the radio. So far, I've changed out 3 caps. The one on the speaker plug, of course, and this one here. Now this one down here, by the way, I'll show you that in a second. This one here is the capacitor, the coupling capacitor I showed you we tested earlier, where we had, you know, decent audio on the left side and garble on the right. This cap right here is this one right here. Well, I got crap everywhere here. Hang on a second. That one's that one right there, okay? And coming off of each side of the capacitor on the schematic, you'll see R11 and R12, which are both 250K resistors. Well, those are a couple of dog bones. One of them is this one right here. Comes off one side of the capacitor. That lead right there is connected down here to the lead on the dog bone, and the other dog bone is down here underneath that wire. Okay, you can see the lead is connected to the other side of that. They both go to this right here. So, you know, I've got this mindset about dog bone resistors. I don't like them and I want them to go. And there's a reason for it. You know, to me it's like keeping old tires on a 1930 Chevrolet. You know, well, they're good, they're still good. No, you're just asking for trouble down the line. You know, they're only a couple of cents a piece. I got a whole bag of, I don't have any 250s, but I got a bunch of 270s, which are well within tolerance. So let's go ahead and measure these two. You know, some people, they say, oh, as long as the measure's good, it's good. Well, fine and dandy, knock yourself out. I don't like them, I want them to go, but let's just take a look to kind of show you what the resistance is of these two. We've got our leads hooked up to both sides of the one. Let's find out what it is. We're gonna go down to the 2 meg scale. Well, that one's not too bad. It's within tolerance, but it's pushing the envelope. 284 K. It's not too bad. Now we'll go over and we'll hook up the other side and see what that one's got. This one goes hither, and this one goes down in thither. Oh, that one's way out. Look at there, 340K. So that one's got to go. So now it's decision making time. Command decision. What do we do? Do we just change this bad one here and leave the other one in? I say no, and I'm going to give you my reasoning. I'm going to change them both. Now, why would I want to do that if this one's within tolerance? Because once I get everything hooked back up and the electrolytics across the top here, if one of these goes bad, I'm going to have to dig down in there and take everything apart just to get to them. You know, it's not like this one right here, which is easy to get to, right on the, you know, just right on the bottom of the chassis. There's this one, easy to get to. This one, look at this one over here, right there, just easy, no digging at all. See? So let's get these out of here. Look how much digging I'd have to do later on if that one there went bad, which is already bad. But if this one went bad, I'd have to do the same thing. All these things are going to be across it. You know, and I probably wouldn't be the one that did it. It would probably be someone else. Let's change them while we can. I've got those 270s. Like I said, I don't have any 250s, but that's within tolerance. I'm going to change them out now while the changing's good. This capacitor here was also changed, and it's kind of an interesting setup because they had it come around just like I have it right now, and they have it all swirl all the way around and connect to there. But their capacitor was like twice as long as this one. So I've gone ahead and made my coil, and this end didn't require a coil. All I had to do was bend it around the terminal and solder it in place. There was no place to really solder it. There wasn't much of a stub there at all. So it's soldered in, and the idea of this thing here, this insulator, is to keep it away from that ground. So I think what I'm going to do is, after I get everything changed and everything, I'm going to glue a piece of cardboard along the bottom here, especially in this area here. It's pretty close to that ground, and I'll glue a small strip of cardboard or something so it'll keep it from touching the chassis. It probably never would, but I'm not taking the chance. In order to get to this one down in there where it's all buried deep, I'm going to have to take this tab that I ginned up off of this terminal strip. I'm going to have to bend it that way, get it out of my way, give myself some room. Should have plenty of room when I get done with that. Yeah, that gives us a whole lot more room to get there. It doesn't, I know it doesn't look like it in the camera, but it is. Get this clip out of the way, that would help too. Yeah, see, now I can get to this end right here and clip it out, and then clip it out of the other end right here. So I can get to it now, no problem. Now I am impressed. Both of these, I just measured them, both of these 270s right here, and they both read exactly the same. Look what they're reading. I don't think I've ever seen two resistors read exactly the same like that. Anyway, those dog bones are coming out and these are going in. Now one more thing, I hate to keep harping on this, but before you solder your joints, keep in mind these wires have been in there for 88 years as well. Clean them. Clean this mess up. Your solder will stick better. This one there even has paint on it. Look at there. That lead right there has paint on it. We got to try to get that off if we can. I'll just take my knife, and of course it might cook off. I don't want to take the chance. It's not worth it. Go ahead and clean it as best you can, and then go ahead and take the knife blade and just kind of gently scrape there You know, some of it's actually coming off with alcohol. I might be able to get it all off. That would be kind of nice. Yeah, it's going away. So we'll get these things nice and clean there before we solder them up. Both before and after soldering, okay? Now, don't those blue ones look a whole lot better sitting down in there? Yes, they do. They look a whole lot neater, a whole lot better, and a whole lot safer, actually. I'm happy. Right here we have an 800K that looks like it's in, let me get a little closer, a little more focus. It looks like it's parallel to this 270, but it's not. It's attached to this right here. And the other end is attached to down here. And it's supposed to be 800. Let's find out what it is. I keep hitting my camera all the time. Geez, I wish I'd stop that. It's 900, over 900. Okay, yeah, that's within range because it is 20%, but that's too close for me. It's got to go. We're going to go ahead and put this one in. Let's find out what this one is. Haven't measured it yet. This is 820. It's supposed to be. It's the best I can do. The closest I got that I can come. It's supposed to be 820. Oh, I don't like that right there. Let me try a different resistor. Alright, let's try this carbon film resistor here instead of the carbon. That's a little more like it. We'll go ahead and use this one right here. This one is what's called carbon composition. I always like using these because I always found them to be really nice. My entire Heath kit, by the way, I got a new cover for the Heath kit. Forgot to show you guys that. Came in, there's my call sign. Once we get this all set up, I'll have everything done. I've been needing a new cover for it for quite a while. The other one served its purpose. I guess I was about to say, I was talking about carbon composition resistors when I changed all the resistors in here that were bad, and there was a slew of them. They were so far out of tolerance, and even if they were questionable, out they came. I changed them all with carbon composition, and some of them I had to go with film because I just didn't have what I needed, but the overwhelming majority, I think originally this thing was nothing but carbon film. So let's get back at hand here. Now I noticed some of you are saying you're reading a resistor across a cap in parallel with a cap. It's only going to be charging the capacitor and you're not going to get an accurate reading, and that would be true. So let's see, now we've got 854 ohms instead of 700. Let's go ahead and cut this. I got to replace this cap anyway. See what I get now. 854 ohms, same. Put that in the old pipe and smoker. Ladies and gentlemen, the little deal right here is kind of a strange looking affair. What is that? That is a wire wound resistor with a coating over the top, a insulator. And it's probably a woven type of thing underneath there, I don't know. But this one in this radio is 300 ohms, and it is within tolerance. Now, now some of these are real long. They'll run all the way around, way over this way, maybe, and depending on the radio you have. And so the question comes up. Some of them are broken. Some of them don't work at all. And the question is, can I replace that wire wound resistor right there with a regular resistor? Yes, you can, as long as it's the same value or close to it, within 20%. All right, let's get these old nasty electrolytics out of here. I'm going to do one at a time. One at a time. Got that? I've seen some guys. I've seen some guys. They cut a bunch of stuff out and they couldn't remember where it went back. Guess what? I was one of them. I'll tell you what. In the beginning, I made every mistake in the book, and I still make them. That's just the way it goes, you know. Now, there is something you can do to keep track of things if you have a little trouble. Let me show you. Let's say you remove a capacitor or a resistor, and all of a sudden the phone rings, or you get distracted by the kids, the dogs, or somebody knocks on the door. And you know, many times I've come back and I said, where did that thing go? I can't even find that stupid lead down there. Some of the chassis I've worked on have been so busy. What you can do is take one of these jobbies and put the other end there, then go answer your door, answer your phone, or whatever. When you come back, you'll know exactly where the ends of that capacitor or that resistor or whatever it is, you'll know exactly where they go. Or a wire, makes no difference. You know exactly where it goes, okay? Let's back up here a little bit, and then this 700 ohm resistor, the reason I changed it, and of course the cap had to go, but I wanted to change that resistor too. It was just too far out of tolerance. The reason being is R2, it's right here. This is your local oscillator here. And it leads up into the mixer tube. This is how you get your IF. So we, you know, you want to make sure this is good, okay? This right here. This was 700 ohm resistor. We got it, what, 680? Worked out real good. And then I found, let me see, we got our, before I do that, we got our 2 electrolytics in now. And I found one more resistor over here. And that is a 100K, right down in there. And that 100K comes out of the 6K7, which is this little booger right here. It comes down, comes across. No, where's it coming? Yeah, right. Comes down, comes across here. Right there it is, R3, it's 100K. And it measures, I think we got a little break here finally. Measures 104. I'm happy about that. I am very happy about that. And, you know, we'll go ahead and leave that old baby in there. That's really close. And, you know, it's easily accessible if it ever goes to pot, okay? Our last resistor here is a half watt, 25K, 25,000 ohms. And maybe it'll be right, but it's in really good condition. Really nice, shiny outside and everything. Let's see what she measures. Oh my goodness. Now that's a 20%. I could have gone up to 30,500 on that. And as you can see, it's 36,700. Gotta go. Alright, let's try this one. It should be 27. 26.7. That's a lot closer to 25. I like that. Let's get it in. Now, one more thing on soldering. Hopefully I've answered a lot of questions a lot of you guys had for soldering that have been asking me about. Before shutting your iron down for the day, tin it on both sides, okay? Stick it in a holder. I use a 60 watt. I like that iron. It's got the kind of tip I like. I don't like those big guns. Sometimes, you know, modern day electronics, you can't use those big guns a lot because the components that they solder with, if you use that gun on there, it puts out a field around the end of that really big field, and it wipes out the component because they're so sensitive. So I'm not sure how they do that, but those big old guns, they're great for chassis, soldering stuff to the chassis and all that. But you know, your everyday soldering, you know, your Weller 60p, I think it's called. Anyway, no, yeah, W60p. That's the one I always use. They last a long time. They cost a few bucks, but you get your money's worth. Well, that's about it, guys. If all you learned today with this video was to be super duper careful inside a chassis after the thing is turned on, and if you don't know what you're doing, stop and get somebody to help you. It's a very dangerous thing. You can die from this. So if you learned that and you plan to do exercise, very good safety and learning before you do it, then this video will have been a success. Next time, we're going to take these out, or this one, and the last one there. Shouldn't be that long, just a piece of cake. Until next time, this is John.